voice, it picks up mine. Okay. And then what I can do is I can post the video online because I found that the video is way more helpful than the handwritten notes. Okay. So then you just copying that. So it's easier for you. And then if you forgot, you missed something, you need to go back and do it again, you can go back and see it. All right. My old website, see the one up there in the front of the room we talked about, the Weebly. If I don't post a video, that's a good place to go check, and I'll try to link that to places too so you can get to it for the old version of the video. Okay. The notes, sometimes it's an example or two off, but it's typically the same lesson. Okay. I like to list them by the section number. Notice that I use the section numbers. It might be a good idea, it's not written in there, but under where the title is, you might want to write the section numbers down. Okay, just so you know how that correlates with whatever we're doing. And notice it says Algebra 2, that means I'm using the Algebra 2 book, not your yellow pre-calc book. If it doesn't say Algebra 2 after it, it's the pre-calc book. Okay, and I'll tell you kind of when we switch over to that. Okay, doesn't like my color scheme when I do this. All right, so we're going to talk factoring today. So the idea that the goal we're trying to get to is how to factor a trinomial and how to use it to solve a quadratic equation. In Algebra 1, we started with everything linear. This is Algebra 2 and beyond, okay? Advanced math, we're starting with quadratics. So we're starting with everything squared, okay? We're just going to jump right into it, all right? It's going to seem that, like we are going really fast. We're going to do a bunch of different types of factoring today. In Algebra 1, you would have spent a week learning all these factorings. We're going to do it in the next 25, 30 minutes, okay? All right, so we got some vocabulary here, and this is a word that's really, really important to Mrs. Ballard. With no leading coefficient. A leading coefficient, remember, is the number that's in front of the x squared, okay? So when we do a number in front of the x squared, all we use is the magic x. The magic x should look familiar, right? We all know what that is. We've seen that before here at Talkwitz. If you came from somewhere other than Talkwitz, you might not do the magic x. This is what we've all kind of at least start our factoring with here. It's a technique. It is not the only technique to factoring, okay? So I'm going to show you this one. If you have another way you do it and you can get it right all the time, great, okay? So what you want to write up here as a reminder is what you want to get two things that multiply to the top and add to the bottom. And it's better for me to just show you how to do this one than to try to explain it without the numbers there. That's kind of your reminder when you're looking back through your notes. You multiply to the top, you add to the bottom. All right, so for the top of this magic x, what I do to get there is I take this number in front and that number and I multiply them together. But in this case, it's really just the number in the back, right? Because it's 1 times 20, so I put a 20 in the top. And I'm going to put the number from the middle in the bottom, -9. To fill in the other two numbers, that's where I'm going to get two numbers that multiply to the top and add to the bottom. So what two numbers would we find for that? You don't have to raise your hand, just call out the answer. Good. I use choral response a lot, so I expect everybody in the class to kind of be participating and answering, okay? All right, and when we don't, that's when I start calling on people. All right, so the way that this would factor would be x minus 5 times x minus 4, and this is because it doesn't have a leading coefficient. If I was taking a test and I had extra minutes left, I would check this by doing FOIL. That's why we teach FOIL first, okay? All right, let's try another one. There's only 3 of these. So, again, I have a trinomial. Do I have a leading coefficient? No, but whenever I have a trinomial, I go to the magic x. What number is going to go in the top of the magic x? Perfect, good. What's going to go in the bottom? Good. Two numbers that multiply to -12 and add to 3. Nothing?
It's 3, 4, or 2.
Okay, so our choices are 3 and 4. Okay, 2 and 6. Is there another choice? 1 and 12. Don't neglect that 1 and 12 one. That one comes up quite a bit, actually. Are any of those going to get us a 3 with a positive or negative in any way, shape, or form? No. So this one is, I like to throw these in a little bit. Now, I do not expect your entire assignment to be not factorable. That would be silly. Okay? There might be one at the most that's not factorable. Okay? But you need to be aware that not factorable exists. All right? Okay. There's another one there, right? Okay, I want everybody to try that one on their own. Fill in the magic x and then write the two binomial terms. Okay? And you might want to make sure you try it because I'm going to probably call on somebody. Okay, so I'm going to put a 48 in the top and a 14 in the bottom, right? Everybody agree with that? All right, Svea, what'd you get in the other two spots?
6 and 8.
Do we agree with 6 and 8, everybody?
Yes.
All right, good job. There's no leading coefficient, so I just write down x plus 6, x plus 8. I could FOIL it to check it. Okay? All right, kind of boring with no leading coefficient up there, so let's move on. All right, so now we have with a leading coefficient. Again, I'm showing you a method that I teach very well. Okay? This is not the only method to do this. From the Magic X, every teacher at Talkwitz has their own little twist on this. Is that okay to have a whole bunch of different ways to do the same thing? Absolutely, because maybe you like one of them better than the other. Okay? I'd like you to try mine today. Okay? If you don't like it, you can, as long as you know a way to do it, default back to that way. It's okay. As long as you're showing me your work and you're not copying your answers. Okay? So, factoring with the trinomial with the leading coefficient, we multiply these two things together, which we were doing before. It was just a 1 before. Okay, so it's a times c goes in the top, the b goes in the bottom. Okay, you're going to find two numbers here. I'm just going to make them asterisks right now. Okay, I don't know what the two numbers are, whatever they are. To fill out the box, all this is a multiplication table. Yesterday we did add, subtract, multiply. Today, factoring is divide. Doesn't say divide, but that's what factoring really is we're dividing that polynomial up. Okay, so I gotta undo the multiplication table. Yesterday we used it to multiply in. Today we're going to use it to undo things. Okay, that's all that this is a multiplication table. Top left hand corner is going to be ax squared. Bottom right is going to be the c. The other two parts, okay, come from whatever you got in the Magic X. Does not matter the order, okay, but you're always going to follow it by whatever variable is in the middle. If it's a q, put a q. If it's x, put an x. If it's an x squared, you put an x squared there, because sometimes that comes up. That'll come up tomorrow, okay? All right, so let's try this. I'm going to go really slow, okay? So we start with, do we have a leading coefficient?
Yes.
Yes. Okay, so we know we have a trinomial. We know we always got to start with the x when we see three terms, the Magic X. What's going to go in the top of that Magic X? Negative 21, because I have to multiply the 3 and the negative 7 together. All right, what's going to go in the bottom? Good. I need two numbers that multiply to 21, negative 21, and add to 20. Do we agree with that? Okay, we're all good with that. Now, I have a leading coefficient. When I have a leading coefficient, that means I need a box. Or whatever other method you used to solve it in the past, okay? That's the indicator, though, is when you have that leading coefficient, you got to do more, okay? What did I say goes in the top left-hand corner? Which is going to be what in this problem? 3x squared. Okay, so for this problem, what's going to go in the bottom right-hand corner? Good. Okay, I'm going to change colors so you can kind of see the movement here. All right, then these guys, doesn't matter the order, but everybody follow my order while we're learning this, okay? I'm going to put the 21 here and the negative 1 here, and then I'm going to put an x after it. And I'll tell you why in a minute here. I like this method so well, okay? So now I'm going to ask myself a question, and it's always based off of this top left-hand corner box. What times what is 3? 1 times, that's not hard, right? We know what 1 times 3 is. It's typically a prime number or a 4, and we can know the factors of all those things. All right, so now you're going to use division, right? I said it was division. Is 3 ever going to divide into the 1 nicely?
No.
No. Will 3 divide into the 21?
Yes.
So I'm going to pop the 3 outside here, and I'm going to put the 1 on the top. So all I did was 3 times 1. I took that 3 apart. Notice I threw the x's after it because it was an x squared. Okay. Now I'm going to divide. 3 divides into 21 how many times? 7. 1x divides into negative 1x how many times? Negative 1. Now here's why I like it. We haven't done anything with that last box yet, right? What's negative 1 times 7? It just checked itself. Okay? Could you do it by pulling out greatest common factors? What's the greatest common factor of 3x and 21x? It's 3x, right? What's the greatest common factor of 21x and 7? 7. You can pull out greatest common factors. I like thinking about it the way I did it because we have that checkbox. And then I don't necessarily have to go FOIL it, okay? Because I have that checkbox, all right? Again, we're practicing my method. If you've got another method that works for you, great, use it. Okay? I'm okay with that. Do I have to write it in this order? I can move the x plus 7 up front and the 3x minus 1 back here. I cannot switch where the terms are inside the binomials, though. Okay? I can't trade those around. All right, let's try it again slow. A little bit faster than last time, but still slow. Okay? What number's going to go in the top of the magic x? 30. Good. All right, what number's going to go in the bottom of the magic x? Negative 17. Good. Okay. And two numbers that multiply to 30 and add to negative 17.
Negative 15 and negative 2.
Good. Do we have a leading coefficient?
Yes.
Do we need a box?
Yes.
Yes. So whenever we have the leading coefficient, and we're all going to learn those words, leading coefficient. Okay. Eventually, we're all going to say that together. It's only the second day, so I'm not forcing it yet. Okay. I will do one by the end of the period.
We'd have to do the box.
You do not have to do the box, but I'm going to show you the box today. Okay. All right, because I'm only going to teach one method. All right, you can use whatever method works for you. All right, top left-hand corner of the box, what are we going to put? 5x squared. Good. Bottom right-hand corner, what are we going to put? Good. What's going to go in those other two spots? Yeah, and it doesn't matter where I put them, but you're going to follow me today. So we're going to put negative 15 in the top, negative 2 in the bottom, followed by x's. Remember that came from right here. All right. What times what is 5? 5 times 1. Does 5 divide the 2? No. Does 5 divide the 15?
Yes.
Yes, so I'm going to put the 5 on the side and the 1 on the top. Do I really have to write the 1? No. I'm doing that because I'm using that to emphasize my brain. I got to divide 1 in. Okay, but when I write my final answer, I drop the 1. All right. How many times does 5x divide negative 15x? How many times does 1x divide negative 2x? Negative 2 times negative 3 is. It's important to do that because I know I got it right because that box worked out. Okay? And now I have to write it off of the big box. So I've got 5x squared, or 5x minus 2 and x minus 3. Again, I could write that in either order. Okay. We are going to try the next two here. I'm going to do the next one with you. We're going to go a little bit faster. Okay, and then I'm going to have you do one on your own. Okay? All right, so on example 6 here, how am I going to start the factoring? What am I going to use?
8 on top, negative 9.
What's this thing called?
Magic X.
Magic X. Okay, so what am I going to put at the top of the Magic X?
8.
8. What's going to go at the bottom? Good. Two numbers that multiply to 8 and add to negative 9.
Negative 8, negative 1.
Good. Do I have a leading coefficient?
Yes.
So what do I need to use?
4.
Box. Okay. Top left-hand corner of the box is what? Good. Bottom right-hand is 2. The other two numbers come from my Magic X. So I'm going to put the negative 8 and the negative 1 in there, followed by x's. All right, this one's a little bit different. We have some possibilities. What times what is 4? 2 times 2. Okay, so let's start with that. Does 2 divide the negative 1?
No.
So can I use 2 times 2?
No.
So what's my other possibility?
4
4 times. That's why I'm showing you this one, right? So you can see that there's a difference there. Okay, does 4 divide the negative 1? Does 4 divide the 8?
Yes.
Yes, so I can put the 4 there and the 1x on top. And now I'm going to do my division. How many times does 4x divide negative 8x? Negative 2. How many times does 1x divide negative 1x? Negative 1. Negative 1 times negative 2 is 2. So that checks out. So I'm going to write x minus 2. And again, the order doesn't matter. 4x minus 1. There's my final answer. All right. I want you to take about a minute. I want you to try example 7 on your own. So everybody's going to do example 7 right now. Okay. Give you about 20 more seconds or so to finish it up. All right, let's check it together. Okay. So Anthony, what'd you get in the top of the magic X? 36. Good. What'd you put in the bottom? 12. Good. All right. Desire, what'd you get for your two numbers in your magic X? Two numbers that multiply to 36 and add to 12.
6 and 6.
Good. All right. This one's special, isn't it? Okay. We're going to see how many of you are super cool at the end. All right, everybody. Do I have a leading coefficient?
Yes.
So what do I need to use? Box. Okay. All right, everybody, what's going to go in the top left-hand corner of that box? Good. Bottom right? 4, and what's going to go in the other two spots? 6 and 6. All right, what times what is 9? 3 and 3. Does 3 divide the 6? Yep, so I'm going to put 3 on both sides. How many times does 3y divide 6y? 2, and again, 3y divides 6y. Check it. 2 times 2 is 4. 3y plus 2 times 3y plus 2. Is there another way I could write that?
3y plus 2 parentheses 4.
And if you did that, you're in the super cool club. Okay, so does it matter which one I write though? No. Do I need to be aware of both? Because guess what? Multiple choice, they could give you this. Or multiple response. Remember SBAC, we loves those kind of things. They like to have the check boxes where you'd have to check both of them off. Okay, that they're both right. Okay, I can't written out. I accept both answers. Okay, but you got to watch the multiple choice. You got to be aware of both. Okay, all right, let's keep going. This one's easier. Okay, the box is tough. This one's easier. Okay, so square numbers. Give me some examples of square numbers. What are they? 4, 9, I heard. 16.
25.
Anybody see them up in the room anywhere? Yeah, if you look up at the front of the room, and these are always up there, okay? The front of the room, both sides has it as this. They have number, square, cube. Number is the original number. The middle one is the square of that number, and the third one is the cube of that number. We'll deal with cubes tomorrow, actually. So basically, the square root of 4 is 2. You go backwards across the chart. You go to the left across the chart, and it gets you the square root of it. So in order to recognize difference of squares, two things. It has to be a square number, or a square term. Remember, even exponents are square terms. And it has to be, and I can't emphasize this enough, a difference. If it is a sum, it is not factorable. Okay? So in order to do the difference of squares, and I would write this over the top so you remember, square root of the first term goes in the front. Square root of the last term goes in the back. Make one a plus, and one and a minus. Okay? Alright, let's do a couple of these. So, do I have square terms? Yeah, and notice, how many terms do I have? Do I have 3 terms still? 2. So 2 is an indicator. I have 2 terms. I need to check if they're squares. Okay? So 2 terms. I am going to do what with the first term? No. What's this operation right there? Square root. Okay, what's the square root of x squared? X. What's the square root of 25? 5. Make 1a positive and 1a. Does it matter what order I do the positive and negative in? No. Pick an order. Done. Looks like we did no work, right? Because it was one line. Okay. That's just the way these go. All right. Look at example 9. How many terms? 2. So I'm going to check for squares. Do I have square terms? Yes. And it's good to check for squares because guess what? Tomorrow we're going to change that. We're going to add cubes in here. Okay. All right. What's the square root of 9x squared? 3x. Good. What's the square root of 64? 8. No, yeah, 8, right? Yeah, I'm messing up in the 4. All right, what do I write in there now? Plus and minus. All right, I'm going to give you 45 seconds. Do the next 3 problems. So finish off that section. All right, we ready? I'm going to check them. All right. Samia, tell me what you got on example 10 here.
I got x plus 7.
Good. Good. Do we agree with her?
Yeah.
Absolutely. Good job. All right. Example 11. Thomas, tell me what you got on example 11.
4x minus 1. 4x plus 1.
Good. Does it matter what order they're in?
Nope.
Absolutely not. Came up with an 8 during first period. What was wrong with the 8?
They divide by 2 rather than 2.
Yeah, they divided by 2 instead of taking the square root. Common mistake though, right? And it's not, even if I call and you get it wrong, guys, it's not bad. It's good to talk about wrong answers because then hopefully we don't get the wrong answers on the test. Okay? All right, what about 12? What did we get on 12?
X plus 4, x plus 4.
Are we allowed to do a sum of squares?
Yes.
No.
What was the method called?
The difference.
Difference of squares, right? Difference of squares means subtract. I am not allowed to do a sum of squares. So on the sum of squares, if I tricked you, hopefully not, it's not factorable. And I did as I was walking, or I didn't walk around in that one last period. I walked around. They were, a bunch of them were getting it. Okay, let's keep going. There is a rule of factoring that is actually the first rule of factoring that I didn't teach you. Okay, yet. Always, 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 always factor the greatest common factor out first. So write always in first in the 2 blanks. Okay, so basically what we do is we take out whatever the common factor is first, and then we do difference of squares, or we do the magic x or the magic x in the box, or whatever other factoring we learn. Okay? So we're trying to do about 3 of these. So GCF, or the greatest common factor, what's the same or a number that I could divide into both of those terms? 5. So I'm going to pull that out front. How many times is 5, or what would I have left over for the 5x squared? Good. What am I going to have left over for the negative 45? Am I done factoring? No. What kind of factoring is this? Good. You need to know the names of the different types of factoring because I'm going to ask. Okay? And it's more just a conversational thing. I'm not going to have you write the names down on the test. Okay? But you need to be able to have a conversation about it. All right. So difference of squares. What's the square root of x squared? X. What's the square root of 9? 3. Make 1a positive and 1a negative. Okay? All right. Nothing else, right? I can't factor it anymore?
No.
Sometimes this will be a 4th power, and sometimes you can go down further. Okay? So you just got to watch. All right. Example 14. GCF. 2. Okay. How many times does 2 divide 6q squared? Okay, how many times into negative 14q?
7.
Good, and how many times into 8? 4. Trinomial. What am I going to try next? Magic x. Okay, good. So what's going to go in the top of the magic x, everybody? Good, and then the bottom?
Negative 7.
2 numbers that multiply to 12 and add to negative 7.
Negative 3, negative 4.
Do we agree? Everybody okay with negative 3, negative 4? Okay, do I need a box?
Yes.
Why?
Because there's a thing in
Okay, what is this called? Okay, we're all going to say that, okay? So I'm going to ask the question. This is the answer I want. I'm going to tell you the answer, okay? It's good when the teacher tells you the answers, right? And I ask, do we need a box? And you say, yes, okay? Why? And what is the answer to why? Leading coefficient. Okay, so when I say why, you say leading coefficient. All right? If there's nothing else you learn this year, you will know leading coefficient and zero product property, and those are 2 things I taught you the second day of school. Okay? Those are the 2 things I want you to learn this year. And then it's over, right? Don't worry about the other 178 days. No, that's not right. But oh, we're going to do this one here. So that's the one we're going to do or deal with. The 3q squared in the top left, 4 in the bottom right. I'm going to take these 2 numbers from in here. Negative 3 followed by a q and negative 4 followed by a q. All right. What times what is 3? 3 and 1. Is 3 going to divide the negative 4?
No.
Is 3 going to divide the negative 3?
Yes.
Yes, so 3q and 1q. How many times does 3 divide negative 3? Good. How many times does 1q divide negative 4q?
-4.
Check it. Negative 4 times negative 1 is 4. It works out. So I've got q minus 1 times 3q minus 1. What did I miss?
You have to put this square.
Huge mistake that's usually made. Okay? We forget that we pulled that 2 out and we forget to write the greatest common factor down. That's probably the biggest mistake on this kind of problem on the test. Okay? So always make sure you drop it. In fact, I'd probably write it down as soon as I was starting as soon as I was starting this stuff so I didn't forget it at the end. Under the stress of a test and a time, got to finish it in the class period kind of thing, you tend to forget those things. And you don't want to make that silly mistake. Okay? All right. Let's try 15, and then we're going to skip 16. So we don't always do every problem sometimes. All right, GCF. 3, good. All right, left behind. What's left behind for the squareds? 4p squared was left behind for the 21. Good, and for the 3? Okay. Trinomial, what do I have to do next? Magic X, 2 numbers that multiply to 4 and add to negative 7. Does it work?
No.
No.
So
Is the problem not factorable?
No.
Did I factor?
Yes.
I took out a 3, so that's the factored answer. Okay? When you factor out a GCF, you did factor, you don't write non-factorable. Okay? All right, let's skip 16. Let's look at this box here. Okay? I want to make sure we fill that in there. So sometimes when these boxes are there, it's sometimes if you need to go read about it again, this sometimes can give you some hints about things. Sometimes it's vocabulary. This one's more vocabulary than anything else. You can use factoring to solve certain quadratic equations. And I'm going to abbreviate this, quadratic equation in one variable can be written in the form ax squared plus bx plus c equals 0, where a does not equal 0. This is called the standard form of the equation. The solutions of a quadratic equation are called the roots of the equation. If the left side of ax squared plus bx plus c equals 0 can be factored, is the next word, then the equation can be solved using, and this is the next important set of terms I need you to know, zero product property. All right, so what on earth is the zero product property? That's the next box, right? So this is the name that we give to taking two factors, setting them equal to 0, tearing them apart, and solving for them. That's the zero product property, okay? So if the product of the two expressions is 0, then one or both of the expressions equals 0. In algebra, if a and b are the expressions and a times b equals 0, then either a equals 0 or b equals 0. The way that we would do it, okay, the example, they've already factored something. They take both of those terms, set them equal to 0, and then they solve them. So on this one, I would subtract 5 and get a negative 5. On this one, I would subtract 2 and get a negative 2. All right. We're going to do a couple of these. I'm not going to do them all. I'm going to choose to do example, what's the next one here? I'm going to do 17, and then I'm going to skip and do, actually, you know what? Oh, we've got time. Let's not do 7. Let's do 18, because 18 is harder, okay? And then we'll probably do the last one, 20, okay? It's already set up, it's equal to 0. Notice our instructions have changed to solve, okay? So I've got to actually get a number answer. So, trinomial, what am I going to do first? Magic X. So two numbers, or what's going to go on the top? Negative 2 numbers that multiply negative 24 and add to 10. What are we getting? 6 and 4, which one has to be negative? Oh, wait. Can I use 6 and 4? No, I can't. What else do I have? 12 and 2, which one would have to be negative? Does that one work? Okay. Do I need a box? Okay, now everybody answer the next question. Why do we need the box? Good. Leading coefficient. Okay, so top left-hand corner is going to go that 3x squared. Bottom right is going to go that. I didn't leave myself a lot of room for my box, did I? All right, so from the magic x, I'm going to put in the 12 and the negative 2, and I'm going to follow them by an x. All right, what times what is 3? 3 and 1. Is my 3 divide into the 2? Does 3 divide into the 12? So that's how I decide where to put the 3. How many times does 3 divide the 12? 4. How many times does 1x divide the negative 2x? Negative 2 times 4 is? Negative 8. So we have x plus 4 times 3x minus 2. And if I look at this equation, I still have to drop down that equals 0. Okay, so the answer to the next question is, I usually will ask, what property do we need? And your answer is 0 product property. You ready? What property do we need to use next? 0. Good. And that means, that's the words or the vocabulary that means we split them up and set them equal to 0. Because it sounds nicer than we split them up and set it equal to 0. All right, what am I going to do with that 4? Good. You guys, you're in advanced math class. I'm not going to write this down. If you need to write it down, write it down. Okay? But I'm going to expect that we can do that in our head. All right, what are we going to do with that 2? Add it, and what are we going to do with the 3? Divide it. Are we going to get a fraction in the end? That's okay. At least we didn't have to work with the fraction in the middle. I know fractions scare us sometimes. Okay? They're our friends. Okay? All right, let's look at 20. What's different about 20? Yeah, I said it's not equal to 0 yet, right? So how do I get that equal to 0? What am I going to do with that 2 to move it? Good. All right, trinomial, what am I going to do next? Magic x, what we're going to need 2 numbers that multiply to 2 and add to negative 3. Negative 2, negative 1. Do I need a box this time? No, there's no leading coefficient. We're good. So x minus 2 times x minus 1 equals 0. You guys, you can always use the box even without the leading coefficient. It's just way more work. Okay? So if you can recognize when there's a lead and when there's not, that saves you time. Okay? All right. What property do we need to use?
0.
Oh, good. Some of us remembered. All right. What are we going to do with that 2? Add it. What are we going to do with the 1? Add it. There's your 2 answers. And just so you know, and this is going to come up more and more, that exponent tells you how many answers you should have. It's kind of a nice little check. So I have an exponent of 2, I got 2 answers. I got an exponent of 3, I should have 3 answers. Okay? We're going to focus a lot of the first semester on getting answers to those kind of problems. Okay? All right, so the homework, let me show you where the homework's at. Okay? So let's go to, so open your Chromebooks up again. Okay, I posted it already for you because remember I'm not going to copy the worksheet, right? If you absolutely can need a copy of the worksheet, you can come see me about it. All right, so under Unit 1, you'll notice I dated it for you. And eventually we're going to get a Google Calendar running too so you can see it in calendar form because sometimes that works better for us. Okay, I have homework number 2, practice, and I give you the numbers. So notice it says 1 to 28 first column, and 1 to 27 first column. So I'm going to click on that link right there and grab the worksheet. Let's talk about what first column means. Okay? First column means I start here at 1 and I go down like this and do those problems. Okay? Until I see the number 28 and I stop. Am I going to do anything over here? No, I'm not doing, because you guys, we wanted you to practice, but we didn't want to kill you with homework. Okay? Because you don't need to do 30 problems on that. Probably doing, 11 or 12 of them is enough to get us where we need to be. Okay? Make sense? Everybody understands what the homework is. And we covered 2 sections today. That's why we did the 2, you have the 2 different pages there. Okay? So, where do we write our homework in? Spiral notebook. Notice, did I collect homework today? No. Okay, so what's going to happen? And I'm going to wait and see. I'm hoping that we have our notebooks by the end of the week. Okay. I will typically come around and I will stamp. Okay, and I'll give you a stamp on your homework assignment, and I'll give you a stamp in your notebook. Okay. Because then from the notebook, then I look at it, and if you have 5 stamps for the week, I only put the homework in once a week. I don't put it in every day. Okay? So we're going to hold off, and I will try. Hopefully we'll have the notebooks in the next day or two, and I'll come around and stamp once we got our notebooks. Okay? Again, you need to attempt every problem to get credit. If you just do part of the assignment, I do not give you credit for the assignment. You have to try every single problem. Okay? Make sense? All right. So announcements are going to go here in just a second. So if you guys want, I know we're kind of getting close to the end. You know where the homework's at. You guys remember when we shut down the Chromebooks, you log out and you shut down.